Good morning, class. This is Sir Emilio T. Tare Jr. and welcome to our Day 8 of Mathematics class. Today's learning objective is to find the general term or nth term of an arithmetic sequence. To start our discussion, let us review first our general term of an arithmetic sequence. So, what is the equation that we use to find the general term of an arithmetic sequence? Very good. It is a sub n is equal to a sub 1 plus n minus 1 times the common difference, which is d. So let's practice how to use this equation, this formula, in finding a general term. So for our first example, we have to find the 21st term of an arithmetic sequence 11, 8, 5, 2, and so on. So here, using our equation or the formula, a sub n is equal to a sub 1 plus n minus 1 times e. Let us identify each elements of our equation. So we have here 4 elements to identify. First, a sub n is a sub 21 because we are looking for the 21st term. So if a sub n is a sub 21, then n is 21. Next, how about our first term denoted by a sub 1? It is very good, 11. And our common difference is, so get the common difference of each term, each pair of term, second and first, third and second, fourth and third. So you will get negative 3. Very good. So our sequence is decreasing, therefore our common difference is a negative integer. So our a sub 21, let's substitute it to our equation, is equal to a sub 1, which is 11, plus quantity n, which is equal to 21, minus 1, times the common difference, which is negative 3. Now, let us solve first the terms inside the parentheses, which is 21 times 11, minus 1, 21 minus 1, which will be equal to 20 times negative 3. So 20 times negative 3 will be equal to 11 plus negative, so this is a parenthesis, negative 60. Very good. So by adding 11 and negative 60, our 21st term will be very good, negative 49. Okay. Now, let's proceed to our example number 2. Find the 36th term of the arithmetic sequence 5 blank 17 and so on. So, from this arithmetic sequence, as we can see, we are the second term is not available. So first, since we have first and third term, then the second term is the arithmetic difference. So our a sub 1 is 5, our a sub 3 is 17, and our formula for a sub 2 or the arithmetic sequence is a sub 1 plus a sub 5 over 2. Our a sub 1 is 5, while our a sub 3 is 17 over 2. 5 plus 17 is equal to 22 over 2, and our a sub 2 is equal to 11. So now we have our 11 as the a sub 2. Now, so if 11 is our a sub 2, what is our common difference? Very good, 6. The common difference is 6. Now, from the formula, a sub n is equal to a sub 1 plus, this is n, not b. A sub 1 or a sub 1 plus n minus 1 times d. So, our a sub n, what is our a sub n first? What term are we looking for? Very good, the 36th term. So, our a sub n or the term that we are looking for is a sub 36. And if a sub n is a sub 36, or if we are looking for a sub 36, then n is equal to 36. Now, let us substitute into our formula. A sub n will be a sub 36 equal to a sub 1 is 5 plus n is 36 minus 1 times the common difference, which is 6. So, a sub 36 is equal to 5 plus 36 minus 1 is 35 times 6. So, let us multiply first 35 by 36. So, it will be 5 plus 210. So, our a sub 36 will be 5 plus 210 is 215. So, that's how we get for our a sub 36 or the 36th term if our second term is not given. So, basically, we need at least 3 terms to get the common difference. Just like what we did here. On this sequence, we only have the given is only 2 terms, the first and the third term. Now, let's proceed to our third example. So, find the 62nd term of the arithmetic sequence where a sub 23 is 81 and a sub 47 is 177. So, the only given terms are this one and also this one. So, we have to get the 62nd term. So, as you can see, on this example number 3, or in this sequence, in this problem, unlike number 2, this has no common difference. We cannot get the common difference as easy as what we did in our example number 2. And also, we don't have the first term. So, how do we solve for this one? On this kind of problem, we can use this formula. To get the common difference of two non-consecutive terms of an arithmetic sequence, we use d is equal to a sub n minus a sub k all over n minus k. So, what do we mean by non-consecutive? When we say non-consecutive, hindi magkatabi. On this case, yung magkalayo, katulad nung sa example number 3 natin, where the other term is, the first term is the 23rd term, which is 81, and the second term, or the other term, is a sub 47, which is 177. So, from here, let us solve first for the common difference. So, the d on our equation is the common difference. So, d is equal to a sub n minus a sub k all over n minus k. Let us identify our a sub n, a sub k, and k. So, first, the given are a sub 23 is equal to 81. So, let us make a sub 23 or our 81, our a sub k, let a sub k be equal to 81. So, if a sub k is equal to 81, then k is equal to 23. Next, if a sub n is equal to 177, then n will be equal to Very good, 47. Now, going back to the um, formula, let us now solve for the common difference, which is a sub n minus a sub k. So, our a sub n is 177 minus a sub k, which is 81, over n, which is 47, minus 23, which is the value of our k. So 177 minus 81 is, very good, 96. And 47 minus 23 is, very good, 24. And 96 divided by 24, our common difference is, very good, the common difference is 4. So we have now our common difference, which is 4. Now, we have a common difference. Let us now go and solve for the first term, or our a sub 1. So to solve this, let's have, or let us use our general formula term, or general term equation. So a sub n is equal to a sub 1 plus n minus 1. So this equation, our a sub n and n, we will choose from these two. But to make our life easier, let us choose the smaller one, which is the a sub 23 and 81. So our a sub n is equal to 81. Then our n is equal to, very good, 23. Still, we are looking for a sub 1. We will just use this formula, and our common difference is 4. Now, let us apply each values to our term, or our equation. A sub n is 81, equal to a sub 1, which is our missing term, plus n minus 1 is 23 minus 1 times common difference, which is 4. Now, 81 is equal to a sub 1 plus 23 minus 1 is 22 times 4. And 22 times 4 is what? Very good. 22 times 4 is, what do you think? 22 times 4, very good, 88. Now that we have 88, we have to isolate a sub 1. And to isolate a sub 1, we have to eliminate 88. And we will eliminate 88 by adding its additive inverse, which is negative 88 to the both side of our equation. So our equation will look like this: a sub 1 plus 88, 81 on the left side. Then we will add negative 88. So, 88. Okay, sorry for those spike. I don't know where are they coming from. Going back, 88. Now, since when we add two integers, or additive inverse integers, such as 88, positive 88 and negative 88, we will get 0. That's why what will remain is a sub 1. So a sub 1 is equal to 88, or 81 plus negative 88 is what? Very good, negative 7. So our first term is negative 7. Okay. So now that we have a sub 1 which is negative 7 and common difference which is 4, now let us find the 62nd term or a sub 62. So this will be our a sub n, and of course our n is 62. So to find the a sub or our a 62nd term, we will use the general term formula, which is a sub n equal to a sub 1 plus n minus 1 times b. So our a sub n is a sub 62 equal to a sub 1, which is negative 7 plus n is 62 minus 1 times the common difference, which is 4. So a sub 62 is equal to negative 7 plus 62 minus 1 is, very good, 61 times 4. Now, let us multiply 61 by 4. We will get negative 7 plus 244. Very good, 244. And negative 7, to get a sub 62 or the 62nd term, negative 7 plus 244 is positive 237. Very good. So the final answer is 237, or the 62nd term of a sequence with where a sub 22 is 81 and a sub 47 is 177. A sub 62 is equal to 237. I hope you learned something new today. And again, please take note of all of our lesson for you to review on our incoming quizzes in the future. So that's all for today. Again, this is Sir Emilio T. Tare Jr. If you have any inquiries or concerns, please feel free to chat me. Bye, class!